This video is going to just cover the beginning of 2.4. Basically, we're going to go through the basics on long division of polynomials and synthetic division. Before we get into that, I'm going to go through this division algorithm for polynomials. If I were you, I'd probably just pause the video and read through what this says first. So basically, what this says is if you have two polynomials, f of x and d of x, we're basically going to take f of x and divide it by d of x. These are two polynomials. In order to do that, they have to be of equal degree, or d of x needs to be a smaller degree than f of x. When you divide f of x by d of x, there are unique polynomials, q of x and r of x, called the quotient and remainder, such that f of x will equal d of x times q of x plus r of x. That's basically saying if you take f of x divided by d of x, your quotient, or the result that you will get, is q of x. And then you would have to add to that any remainder if there was one. An easy way to look at that would be if you look at it this way. So I'll write what I had there. F of x equals d of x times q of x plus r of x. So basically, we can relate this by taking f of x and dividing it by d of x. When we do that, we would get q of x up here, and then after we do all the work of long division, the remainder would be r of x. That's how these functions relate. Another way we could write this is f of x divided by d of x would equal our quotient, q of x, plus our remainder, if we have one, divided by d of x. That's how you can relate the functions to each other. So here's the example we're going to go through on using long division to find the quotient and remainder. If our f of x is 2x to the fourth plus x cubed minus 3, and our d of x, what we're dividing by, is x squared plus x plus 1, well, you'd set that up the traditional way, where what we're dividing by would go out front, what's being divided would go under the division bar. Now keep in mind, when you write this out, what you want to do is you want to leave placeholders. Our f of x does not have an x squared or an x term, but we want to leave a spot for those when doing long division. So I'm just going to write plus 0x squared plus 0x minus 3. That way everything will stay nice and organized and easy to read. So remember, you've done this before, but you probably don't remember. What you're going to do is basically you're just focusing on this term out here, and you just take your f of x and you take it one term at a time. So the question becomes, what do I have to take x squared and multiply it by to get 2x to the fourth? Well, without much work, you would realize that 2x squared times x squared would equal 2x to the fourth. So I'm going to write up here 2x squared. So then I double check to make sure I'm right. 2x squared times x squared, well, that's 2x to the fourth. Perfect. And then I take my 2x squared, multiply it by the next term in the divisor. So 2x squared times x will be 2x cubed. And 2x squared times 1 would be 2x squared. And then subtract down. The first terms cancel out. That's what I wanted. That's why I picked this term up here. And then basically, I'm going to subtract and bring down what I have left. And then I'm going to just repeat that same process. X squared times what gives me negative x cubed? Well, that would be negative x. Negative x times x squared gives me negative x cubed. Negative x times x gives me negative x squared. Negative x times 1 gives me negative x. Subtract. First term cancels out just like I wanted. Negative 2x squared minus a negative, that's addition. So I end up with a minus x squared here plus x, and bring down the 3. Do it again. Here we go. I've got x squared. What do I have to multiply it by to get negative x squared? Well, minus 1. Minus 1 times x squared is negative x squared. Minus 1 times x is minus x. Minus 1 times 1 is minus 1. Subtract what I just wrote down. First term canceled out. Perfect. Subtract a negative, I get 2x. Subtract 1, I get minus 2. What does that tell me? Well, basically, this sums up as, if I take 2x to the fourth plus x cubed minus 3 and divide it by x squared plus x plus 1, I get for a result what I have up on top here. 2x squared minus x minus 1. And since the remainder was not 0, I have to add that remainder divided by what I've been dividing by the whole time. X squared plus x plus 1. So then the quotient would be 2x squared minus x minus 1, and the remainder would be 2x minus 2. I'll throw in a couple of theorems here as well. They're pretty quick here. The remainder theorem is simply if your polynomial f of x is divided by some binomial x minus k, then the remainder is going to be f of k. What does that mean? That means if you plug in k into f of x, the number that you get back out will be the remainder that you get when you divide by x minus k. So an example of that is right here. Find the remainder when f of x equals 2x squared minus x plus 12 is divided by x plus 3. So basically, all that's saying is to find the remainder. Well, if you're dividing by x plus 3, your remainder is going to be what you get when you plug in a negative 3 in for the x here and the x here. It's as easy as that. 33 would be your remainder. The factor theorem. Polynomial function f of x has a factor x minus k if and only if f of k equals 0. So basically what that's saying, what this factor theorem is saying is if you plug in some value k and you get 0 back out, then x minus k is a factor. Or if it has a factor x minus k, then when you divide by x minus k, you will get 0 for a remainder. Here's an example of using synthetic division to divide a polynomial by a binomial. So you can only use synthetic division when you are dividing by a binomial. And that binomial needs to be an x minus some number. So the only time you can do it is when you have that type of factor. What you need to do to start is whatever the 0 would be of that factor, that would go up in the little box to the left. In this case, x minus 1 tells us we put a 1 up in the little box. Next, we're going to write out all the leading coefficients of the polynomial that's being divided. Make sure that you do keep placeholders of zeros if you are missing any terms. In this case, we are not. So if you remember from last year, when you do your synthetic division, you're always going to just drop down the first term. Then you're going to take that number you dropped down times 1, since that's what's up in the box. And the answer comes into the next, right below the next number in the sequence. So 3 times 1 is 3. That'll go there. Add the numbers in that column and repeat. 1 times 1 is 1. 1 plus 1 is 2. 2 times 1 is 2. Negative 5 plus 2 is negative 3. Now what this means is, if you take 3x cubed minus 2x squared plus x minus 5 and divide it by x minus 1, you would get this 3 here, this 3 right here, is going to be attached to 1 degree less than what the degree of the polynomial was that x minus 1 was being divided into. So what that means is this 3 gets attached to an x squared, the 1 gets attached to an x, the 2 is our constant, and then this minus 3 is our remainder. we can see using synthetic division is a lot faster than long division with polynomials.